Well, today I'd like to talk about my understanding of the dreaming phenomena from the perspective of understanding the brain as a hierarchical generative model. And I will also try to refer to some knowledge in machine learning, and that may involve some rather technical details, and I hope I can make it as clear as possible. Well, I use the term of hierarchical generative model in the context of the predictive brain theory framework. This theory has been very popular in neuroscience, psychology, and philosophy in the last decade or so, and it is advocated by Carl Friston, Andy Clark, Jacob Howie, and so on. And this theory suggests that the mechanism of the predictive brain is to use the model to generate predictions about the states of the world, and at the same time to calculate the prediction error between the predictions and the actual inputs from the environment. When the prediction error is too high, the brain will either adjust the model itself or modify the environment inputs through the agent's actions. And in this case, the model is a hierarchical generative model, and the error is passed from one layer to another. And we can have a basic idea of the mechanism in this theory by this picture. This is from a website. And I want to provide a new interpretation of many phenomenological experiences of dreams and the evolutionary role of dreams within this framework. And the existing interpretation of dreaming under this framework mainly comes from Carl Friston. He has discussed sleeping and dreaming under the framework of model optimization. As for Friston, model optimization activities of the brain is to reduce the complexity of the model so as to preclude the overfitting problem of the brain, and thus the evolutionary role of sleeping and dreaming included for Friston is to reduce the complexity of the brain model to solve the overfitting problem. Eric Ho has also recently proposed a theory named the overfitted brain hypothesis, saying that the role of dreaming is to help the brain to solve the overfitting problem. And different from Friston, Ho's work is more based on the knowledge of machine learning, and therefore he has understood the overfitting problem differently from Friston. For Ho, the main reason for overfitting is that the training sample of the model is too limited and homogeneous, and that results in a model with too much explanatory power for the available data. And the role of dreaming is to solve the overfitting problem by expanding the training set of the model. And for Ho, he just explained the dreaming. I think he just used this hypothesis to expand the dreaming experience, which is fantasy and which is distinguished from actual life. And I think there are some problems with Friston's view and Eric Ho's view. For Friston, I think there may be two problems. The first is that although Friston has pointed out that the main function of sleep is to prune the connections formed during wakefulness, sleeping and waking period are still seen as two parts with their separate functions, and the continuity between sleeping and waking is not sufficiently portrayed. And the second problem is that I think the problem faced by the brain model may be understood too simply by Friston. That is, the model may not only face the overfitting problem, but also the underfitting problem. And the brain's work to solve the underfitting problem should also be considered. As for the host field, I think his explanation is valid only for fantasy dreams that are different from everyday situations, but not for other dreams that are similar to our everyday situations. For example, we may report dreaming of solving the mathematical problems that are not solved during our daytime, and that is not fantasy. And I think that cannot be explained according to host hypothesis. And on the basis of that, my basic goal is to provide an explanation of dreaming that depicts the continuity between the waking brain and the sleeping brain. And also, I'd like to provide an explanation for most dream experiences, not just for fantasy dreams. And my basic point is that, first, there are two kinds of understanding of the model. One type is manifested in the idea of freestone and whole, which understood the brain model as a whole and discussed whether the model as a whole was overfitting for the data or underfitting for the data or valid for the valuable data. And in their views, the brain model as a whole only has one problem, which is overfitting. Well, I think there may be another kind of understanding of model, which I'd like to argue that the model can be seen, the model as a whole can actually be seen as consisting of multiple submodels, and that each submodel of the brain has different explanatory power with respect to the data, so that some submodels may be underfitted to their data, and some submodels may be overfitted, and some submodels may be fully valid with respect to their data. And on the basis of the second kind of understanding of the model, I think that the brain's activities can be understood as consisting of three parts: solving the underfitting problem, solving the overfitting problem, and using the effective model to process the data. And I believe that both the waking brain and the sleeping, also the dreaming brain, consist of these three parts of activities, and that's exactly the role of dreaming. Also, I think this idea of the role of dreaming can help explain many dream experiences, such as vagueness, incongruity, and narrative feature of dreaming. And the second part is to introduce the overfitting and underfitting problem in machine learning. Well, overfitting problem happens when we train a machine learning model too much tuned to the training set. As a result, the model learns the training data too well, and even the noises of data are explained by the model. Thus, the model cannot generate good predictions for new data. And the overfitting model is embodied in an overly complex model, and there are too many parameters, including some irrelevant parameters. Well, as for the underfitting means that the model does not sufficiently mine the features of training data, and therefore cannot effectively describe the distribution of the existing data, let alone apply the model to the new data. And the overfitting model is embodied in an overly simple model, and there are too few parameters for the underfitting model. And there is an example of the overfitting and underfitting problem in machine learning. In this way, in the task of classification of a leaf, the classification result of the overfitting model would be that he will think that this picture is not a leaf, because the model considers the jag in the training data as a necessary condition for being a leaf, and there is no jag in the new data, and he will say that it is not a leaf. And in this example, the classification result of the overfitting model would be that this tree would be judged as a leaf, because the underfitting model would consider that all the green ones are the leaves. and that are different performances of the overfitting and underfitting model in machine learning, and how to explain the dreaming experiences on the basis of these problems. The first, I would refer to the functional problem solving of dreaming. Well, it is controversial whether dreaming has such a function, but I believe that dreaming has this function, and relevant evidences come from experiments such as Sanders experiments and Cartwright's experiment, which just test the connection between the which has just demonstrated the function of problem solving of dreaming and sleeping. And also, many people may report dreaming of doing unfinished math homework when we were students, and I think that's also an example of the function of problem solving of dreaming. Well, in machine learning, there are always two ways to tackle the overfitting problem. One is to adjust the model by reducing regularization parameters to reduce the magnitude limit of features, or by constructing complex polynomials to improve the model complexity, or by adding data features by combination, generalization, correlation, and so on. I'd like to expand the experience mentioned before in the framework of solving the underfitting problem. That is, the waking brain's model of solving mathematical problems is not sufficient to solve the problem at daytime. And in dreaming, this model continues to be trained for solving problems. Specifically, the brain will try to change the solution formula or discover the connections among the atoms, so to adjust the problem, and that corresponds to adjusting model or the features of data respectively. Well, as for dreaming and solving the overfitting problem, there are two ways, and the cause of the overfitting problem is that there is not enough sample data and the model is too complex. In machine learning, the problem of insufficient sample data is often solved by adding training data, and the excessive complexity is reflected in the excessive variables of the model. And there are two main approaches to dealing with the excessive complexity of the model. That is, one is to reduce the number of existing features, and the other is to reduce the magnitude of parameters by using regularization methods. And we can explain many dreaming phenomena under solving the overfitting problem framework. The first is the incongruity of dreams. Well, also, Hobson, Friston, and Ho all have explained the bizarreness of dreaming under the overfitting framework of the brain. I want to first point out that the notion of bizarreness can entail various meanings, and I will refer to anti-Raffelson's classification because it seems to be clearer. Raffelsson has classified bizarreness of dreams into three categories, which is incongruity, vagueness, and discontinuity. And incongruity means that an element is inconsistent with waking reality, and vagueness means that an element in dreaming is obscure or vague. And discontinuity means that an element in dreaming suddenly appear or disappear or transform. And I will provide different explanations for the mechanism of the three types of bizarreness in Raffelson's sense. As for the incongruity, Robinson has distinguished three cases of incongruity based on the degree of likelihood that inconsistent factors in the dream will occur in the waking reality. Well, I'd like just to divide the feature of incongruity into two categories, and one is the increase of features, and the other is the reduction of features. The former is reflected in the increase of unreal features in dreams. For example, the increase intimate relationships which do not take place in reality. And the reduction of features, for example, the headless monsters or etc. And I think the increase of features can be explained as the brain's generating more data for model training through combination and generalization of existing data features, and so to preclude overfitting. And the reduction of features, it can be explained as the brain's reducing model complexity by discarding features. As for the vagueness of dreams, it can also be explained by solving the overfitting problem. This feature means that things in dreams are usually blurred, and it can be interpreted as a result of the inhibition of sensory input during sleep, and that is according to the predictive coding theory. And moreover, I will interpret this as the brain's reducing the number of features, or the brain's reducing the magnitude of features, so to reduce the complexity of the model. And I think the notion of the precognitive dream is sometimes magic, and it is usually used to describe the experience that in dream we have some special natural power to see future events. And I'd like to give a reasonable, naturalized explanation of this experience. First, I will define the precognitive dream as a kind of dream in which we dream of events that have not yet occurred at the time of dreaming, but it do occur in the time after dreaming. And then I will hold that there are at least two types of the precognitive dream. In one type of the precognitive dream, the scene predicted by the dream has been attended to before dreaming. In another type, the scene has not been attended to before dreaming. This classification is shown in the figure. And I think the latter case can be explained by the brain's response to the overfitting problem. As mentioned, in order to cope with the overfitting problem, the brain will train the model by adding features and generating more training data. And it is possible that some training data happen to partially coincide with events that occur later. And also, as mentioned before, the activity of the brain model involves not only responding to the two problems, but also processing data using effective model. When the brain is awake, this mainly refers to processing real-time data from sensory input. And when the brain is sleeping, this means processing the data that already exists in the model. And that is the submodel is not overfitted or underfitted, so the brain continues to use the existing models to process tasks that it doesn't finish when awake, and without no need to change the model or parameters in dreaming. And many phenomena of dreaming can be regarded as the result of such an activity. First, it is another type of the precognitive dream. As shown before, in one type of the precognitive dream, the scene predicted by the dream has been attended to. Before the dream happens, I think that the process of this type of dream I think that the process of this type of dream is as follows. First, because one hypothesis H1 is attended to when awake, then that helps H1 win the competition with other parameters, becoming the task of brain during speak. And then the brain model invoke other parameters available to generate fictitious scenarios related to H1 in order to train the model to process this task. And eventually, because the trained brain model includes not only the parameters of the task, but also the parameters of the way this task is processed in dreaming, the subject reacts in a manner similar to the manner in dreaming when the event occurs in reality. For example, the subject S was going to have an exam tomorrow, and S gave attention to the task of making sure that there will be no mistakes in tomorrow's exam. And this attention led him to dreaming that he is late for the exam out of the reason C1. And when S woke up, sure he was really late for the exam out of a similar reason C1. That's because not only the parameters of the task, but also the parameters of the way this task is processed have been stored in the brain. Also, it is also possible that that when S woke up, he forgot the content of dream, but was still late for the exam out of reason C1. And in the framework of model, this phenomena can also be explained. This is because although the content of dream has been forgotten, the brain model has been trained during dreaming, and the state of affairs that S will be late for reason C1 has been characterized by some parameters of the model stored in the model and is most likely activated. Also, there are other features of dreaming that can be explained from the perspective model. For example, the narrative feature. While House failed to explain the narrative feature is that since narratives are the way by which human brains understand the world, brain models produce narratives to combat overfitting and improve generalization. Well, my view is that being narrative is the way the human brain, mainly the adult brain, understands the world. It means that the narrative feature is a parameter of the brain model, and it's at the high level of the hierarchical model. When the brain trains itself either to solve the overfitting problem or solve the underfitting problem, or to process data with an effective model, this parameter in the model will function, and that makes the dreaming and that will make the dreaming narrative.
Excuse me, there are 3 minutes for the
okay.
Yeah.
I'm sorry, and I think my explanation can also respond to the spliced dream experiment, which challenge the existence of narrative feature of dreaming. Also, I'd like to interpret the discontinuity of dreaming from the perspective model. That is, this feature means that dream often goes from one scene to another in a flash, and I'd like to and I think the reason for this feature may be that the model has been trained sufficiently for processing some data, so the training is stopped. Or the reason may be that the current model has too much error processing the current data, so the current parameters are pruned. And we can refer to the early stopping strategy in machine learning to understand it. And also, I'd like to point out that our brain is not imperfect, so there may be some phenomena that reflects the imperfect brain, such as such as maybe the same thing may recur in dreams. It is possible that the brain cannot generate data with sufficient diversity, and so the same phase recur in our dreams. And
sorry, I think the PPT is kind of like stopped, or you update, because we see the different now. Yeah, now it's working. Yeah.
Oh, okay. And finally, I'd like to point out that dreaming can be understood as a process of a mixture of multiple processes, which is mentioned before. And the three processes of the brain, as well as the collapse of the brain model, may go on simultaneously. That is, in one dreaming, we may see many aspects of solving many aspects, such as solving the overfitting problem, solving the underfitting problem, using the effective model to process the data, or the imperfect brain perspective. And that's all my idea about dreaming. Thank you.